Hi everyone, I hope you're okay. And I really hope that guys the videos we keep uploading are helping you out. Please note that guys this is the 21st video. Uh that simply means I'm doing question number 21. Please do expect a total number of 33 questions. Organic chemistry is a huge chapter, guys, so be patient. Be patient. Okay, learners investigate the boiling points of four organic compounds given below. We have butanone, uh butane 1-ol, propanoic acid, and 2-methyl propane 1-ol. Okay, this is a ketone, uh, primary alcohol. Okay, let me just write alcohol. And then this is a carboxylic acid. And then this is an alcohol too. It's a chain isomer of compound of butane 1-ol. Okay, let me rank their boiling points because we are investigating boiling points here. Ne? Okay, butanone will have the lowest boiling point. Why? Because it has weak it will have weaker intermolecular forces, which are called dipole forces. Alright, together. So butanone will be ranked the last whenever you compare the boiling points. This will be at position 4. Alright, together. And then we are comparing butane 1-ol, propanoic acid, and methyl propane 1-ol. Propanoic acid has the stronger intermolecular forces compared to alcohols. Why? Because it has two sides of hydrogen bonds. So propanoic acid will take position 1. It will have the highest boiling point. Okay, and then now we are comparing between butane 1-ol and 2-methyl propane 1-ol. Between the two, the one that has a side chain will have the lowest boiling point. So that means butane 1-ol will be at position number 2. Butane 1-ol will have the second highest boiling point, and then 2-methyl propane 1-ol will have the third highest boiling point. So that's how you would rank these two boiling point, these things over there. Ne? Okay. Define the term boiling point is a temperature at which the vapor pressure of a substance is equals to its atmospheric pressure. Which compound, butane 1-ol or 2-methyl propane 1-ol, will have a higher boiling point? Give a reason. I did mention that butane 1-ol will have a higher boiling point. What's the reason behind that? I was answering the previous question over here. Let me just write here. In the meantime, I hope you are subscribing. I'm comparing 2-methyl propane 1-ol and butane 1-ol. Ne? Okay, firstly, both compounds have a hydrogen bond together. Both compounds have hydrogen bond, and both of them have the same molecular mass. You can see that's 74 grams per mole and 74 grams per mole. So that means they are isomers of each other together. Both compounds have hydrogen bond. However, 2-methyl or let me say this, however, if butane 1-ol has a greater surface area. Why? Because butane 1-ol is not branched. Are you together? If you were to draw these structures, you'd have butane 1-ol like this with an alcohol there and your hydrogen atoms, but 2-methyl propane 1-ol will be like this with your alcohol there. Are you together? You can see that this compound over here is more spherical than this one. This one has a greater surface area. Are you together? So it simply means that butane 1-ol have stronger intermolecular forces, and then more energy. Let me rather write like this. Butane 1-ol requires more energy to separate the bonds. Right, together, and hence butane 1-ol has a higher boiling point. Are you together? Yes, both compounds have hydrogen bond. However, one compound is more spherical than the other. The other one has a greater surface area than the other. So the one with the greater surface area will have strongest intermolecular forces, and hence more energy will be required to separate the bonds of the compound that has the strongest intermolecular forces, and hence that compound will have a highest boiling point. Okay, the curves P, Q, R, and S below were obtained from the results of the investigation. X represents a specific temperature. Okay. Which physical property is represented by X? Remember that, guys, we are dealing with temperature, né? And we were told that we are investigating boiling point. Remember that boiling point is a temperature at which the vapor pressure of a substance equals to the atmospheric pressure. So this part of X just represents a boiling point of a particular compound between the four. And then now we are being asked to identify the curve that represents butanone, propanoic acid, and 2-methyl propane 1-ol. Remember that, guys, I have already ranked them there because of their intermolecular forces. I said propanoic acid will have the highest boiling point. So P will represent propanoic acid. This will be propanoic acid. And then I said the Q will be butane 1-ol. R will be 2-methyl it's 2-methyl propane 1-ol, and then this will be butanone. Okay. Butanone is represented by S, propanoic acid, that's P, and then this will be R. Give a reason for the answer in 3.4.2. Propanoic acid has stronger intermolecular forces and hence it will have a higher boiling point. That's the reason. That's how, guys, you're supposed to tackle that question over there. I hope that, guys, the video helped you out. Just stay tuned and wait for more videos. Thank you.